Today is 6/22/23. We're trying to recharge a Kenmore refrigerator with 134A. We're probably going to try to do 4 ounces. So the model of the refrigerator really doesn't matter, but here it is. It is 106.76239,402. And it is getting cold. It used to be 70 in here. Now it's like 30s, 32, 28. So that's a good sign. This fan used to stop working, and now it's working. And then the complaint was the top is cold, bottom is not. We probably have a leak somewhere here, but we're definitely in a great number. We're in 22 range. So I could have charged more than I did because my battery went bad, but I wanted like 4 ounces. So we put a piercing valve in here, and then we have a 30-pound 134A. We needed this adapter that was 1/2 inch female Acme to a 1/4 inch male. And then we finally got that. Let's go ahead and put the battery in. Let's turn this on. Good. Zero it out. So we're zeroed out. Now we put the scale on. Oh, we're 188. So we're supposed to be 188 and a half. So we're good. Let's just give it a tiny bit more. It'll be 4 ounces. The low side is saying 20 something. So now we're gonna give it a little bit more. We're supposed to be 188 and a half. Like this. Close it up. So I'm 188 and a half. So that's exactly 4 ounces, 188.3. This seems like it's a little bit bigger compressor. So let it leak a little bit. So let's just give it like, it's 187 now. So that's 4.5 ounces of refrigerant here now. And I think we are set. So the number now is 188. And we started with 193 and a half. So 188 climbing up is 189, 190, 190. I lost 188 climbing up is 189, 190, 191, 192, and 193. So let's count up, okay? 188 to 189, 190. 191, 192, 193. So that's 5 ounces, and it was 193 and a half. So we put in 5 ounces and a half, and I only wanted to put 4 ounces and a half. So we're close. So you can see the number now is 188. So we're done. We're gonna close this off. That's good. Then we're gonna close our valve up so no gas can leak out. And hopefully when I disconnect this, we have no leaks. Right now it's saying 20 PSI on the low side. Can you go grab me the thermometer gun in the top?
Yeah. So you want it? You want me to check? I feel the cold.
Oh, good. So right now, you're supposed to charge this with the refrigerator running. I can feel a hum, a nice hum. It feels warm. This is the high side. It feels hot. The low side feels cold or cooler. It's saying like 80 degrees. I don't know. Okay, 90 degrees, 92, 96, 97, 98, So let's just call it like close to 100. And the temperature right now in this room is about 70. And this thing up here feels cooler. I don't know why it's in the hundreds. Yeah, it should be cooler. 91, 90, yeah, that's good. All right, 90. So it's almost like a 10 degrees difference. But this definitely feels hot and this definitely feels cool. So that means that's a good sign. And now, let's check out the inside here. So water freezes at 32, so we want this refrigerator lower than 32. So we're at 26, that's less than 32, that's good. 24, 23. 24, 23. 20. All right, so let's just call it 24 at times is the lowest. 23, there you got it, 23. And you can feel this air is much colder. You can see frost building up. And then that's working. And so this thing was definitely low in refrigerant. So the most common reason why it's low in refrigerant is the two type of metal. This is aluminum and this is copper, and there's probably a leak here. So I'll probably bring in a 134A sniffer, and we'll make a little sniffing noise, but there's so much breeze here. Maybe we can actually sniff it or not, but we'll figure that out a little bit later. Or we'll do the sniff when we pull out the power. And I think this problem is, this refrigerator is fixed. So the question is, today is 6/22/23. Hopefully it can last for 3 years. Or if not, we can maybe put some epoxy here, some JB Weld or something here. Hopefully it can handle that cold and hot and 2 different metals. I don't really know the fix on how to fix this, but that's supposed to be a common area here and on the other side. All right, thanks for watching.